Okay, picture this. It's the dawn of the space race. You're at Cape Canaveral, and right there on the launch pad is this massive Atlas rocket, just simmering with explosive power. I mean, we're talking about a multi-story tower of controlled violence, ready to throw an astronaut into the great unknown. And the fire, the noise, the sheer force of it all, that's what we remember. But hidden inside all that spectacle is a really fundamental problem.
No, really, just think about that for a second. How do you actually guide a vehicle that's moving faster than a speeding bullet, aiming for a tiny, precise window in space? You can't just, point it in the right direction and hope for the best. You need a brain. You need a lightning-fast nervous system to keep that thing on course. And the answer? Well, it wasn't where you'd probably think it was.
Sure, the Atlas rocket had its own simple little autopilot on board, but that was really just for basic stability. For the high-stakes precision work of hitting a moving keyhole in space, the real brain wasn't even in the rocket. And why is that? Because the computers back then were massive, they were heavy, and they were incredibly power-hungry. Putting one with enough horsepower on board was just impossible. So the only way to get the job done was to keep the brains of the operation firmly on the ground.
So, let's meet the answer to our steering problem. This machine right here, the Burroughs MOD III guidance computer. It's a name that, let's be honest, has mostly been forgotten. But this was the invisible hand that guided America's first astronauts safely into orbit.
And when I say machine, I really mean it. Forget your phone or your laptop, this thing took up an entire room. The Air Force installed it back in 1958, and it was a total beast of blinking lights, humming modules, and whirring tape reels, all dedicated to one single monumental task.
Now, what made this computer so special was the tech inside. The Burroughs was one of the very first fully transistorized guidance computers. See, before this, computers used these big, fragile vacuum tubes that could burn out at any moment. Transistors were a complete game changer in reliability, and when you've got a person sitting on top of a giant firework, reliability is pretty much everything.
This really shows you the two sides of the system perfectly. On one hand, you had these massive racks packed with complex circuits. That's the raw processing power. And on the other hand, you had this surprisingly sleek operator's console, where human technicians could monitor, test, and basically control this immense digital brain.
So, the big question is, how did this giant room-sized computer actually steer a rocket that was screaming through the atmosphere miles and miles away? Well, it all came down to a constant, high-speed conversation.
Engineers call this a closed-loop guidance system, which you can see laid out here. But I think a better way to think about it is less like a pre-programmed flight plan and more like a live phone call between the ground and the rocket, with the Burroughs computer acting as the world's fastest translator and navigator.
This loop was basically a lightning-fast, four-step dance that just repeated over and over again. So, step 1. Giant radars on the ground are constantly pinging the rocket, asking, hey, where are you right now? Step 2. The rocket's position and speed get fed directly into the Burroughs computer. Step 3. The computer instantly calculates, okay, you're a tiny bit off course, you need to adjust by this much. And then step 4, it radios that exact command right back up to the rocket, which nudges itself back onto the perfect path. And all of this is happening in a fraction of a second.
And get this whole conversation was happening incredibly fast. The data circuits were transmitting at 1,000 bits per second. Now, I know, that sounds super slow by today's standards, but back in the early 1960s, that was blazingly fast, and it was absolutely essential for making real-time adjustments to a vehicle tearing through space at Mach 25. So, all of this incredible technology, this high-speed digital dialogue, it was all about to be put to the ultimate test. It wasn't just about guiding missiles anymore. This time, it was about guiding a national hero.
This is the moment it all came together. On that historic day, it was the Burroughs MOD III that performed thousands of calculations every single second to steer that Atlas rocket and safely, perfectly place John Glenn into orbit, making him the first American to circle the Earth. It worked. It just worked perfectly.
And its success wasn't just a one-off thing. The MOD III was a total workhorse for the early space program. It guided all the crewed Mercury Atlas missions, and then it was so reliable that they gave it another critical job during Project Gemini, guiding the unmanned Agena target vehicles that our astronauts had to practice docking with in orbit.
This quote from the official documents, it really gets to the heart of its massive responsibility. See, it wasn't just about steering. Its ultimate final command was to cut the engines at the exact microsecond the rocket hit the perfect position and velocity. A fraction of a second too early or a fraction of a second too late, and the whole mission could fail. That's the mind-boggling precision we're talking about.
And on top of that primary role, this thing was a multitasking genius. It was handling the automatic flight control, it was crunching numbers for the range safety officer in case things went wrong, and it was simultaneously displaying and recording all the flight data for the engineers back in mission control, all at once.
So, what happened to this groundbreaking machine, and who are the people actually flipping the switches and reading the printouts? Well, its story didn't just end when the rockets went quiet. A machine this complex doesn't just run itself. These were the human brains behind the electronic one. Burroughs technicians like Richard Houle, George Liner, and Robert Wortman. These were the guys who ran the diagnostics, who maintained all that intricate circuitry, and who ultimately made sure this computer was ready to go on launch day.
And the contrast between then and now is just staggering. This machine went from being one of the most critical, high-pressure pieces of technology on the entire planet to a silent, revered artifact. It's a physical, tangible link to a time when a room full of transistors was our only ticket to the stars.
And you know, the great news for all you history buffs out there is that you can still see these incredible machines today. The actual Mod III computer that guided John Glenn is preserved at the Henry Ford Museum, and its earlier sibling, the Mod I, is on display right where all the action happened, at the Cape Canaveral Space Force Museum.
So the next time you see that old footage or those early, heroic launches, just remember that the real action, the silent, lightning-fast thinking, it wasn't just happening in the cockpit. It was happening right here, in a cool, quiet room back on the ground, deep inside the circuits of a forgotten hero.
It really makes you wonder, doesn't it? As we're always looking to the future, it's worth taking a moment to remember the hidden giants on whose shoulders we're all standing. What other invisible brains and unsung machines are out there, just waiting in the archives of history for us to rediscover?